First, congratulations! We are now done with graphing quadratic functions. To be honest, at the beginning of the chapter, I was very scared because I know that it's one of the most important parts of Algebra 1 that you will need when you move on to Algebra 2 specifically, and not being in school to teach you that in detail, it was scary for me. But with careful planning, consistent use of the graphic organizer. I know I gave you a lot of those graphic organizers and key features. I was able to see not just the expected outcomes, but even more from you guys, so I'm really happy. I do hope the shortcuts and all the other techniques that I showed you will help you retain some of the information learned. So our topic this chapter 9, is still similar to what we did previously, but instead of using graphing as a way of solving, we're going to do it algebraically. So pretty much the last two sections, the last two chapters, will be more computational than graphical. Okay, so to begin our study with solving quadratic equations, we need to have a quick review of properties of radicals. So our main question for our first lesson is, how can you simplify, multiply, and divide square roots? Now, this sounds familiar, doesn't it? Um, in the lesson on exponents, we also learn how to simplify expressions that have exponents. We learn how to multiply exponential expressions. We also learn how to divide them. So pretty much this is just the reverse operation of exponents. So instead of raising them to a power, we're going to use radical expressions instead. So what are the two most important rules that we will learn today? So the first one is the square root of AB is equal to the square root of A times the square root of B. So this is for products of radicals. What does it basically make you do? It allows you to break down a certain product into two smaller values, right? Now, the second one is the quotient of radicals. So if you're dividing A divided by B and then you're getting the square root of that, you can actually get the square root of the numerator and then divide it by the square root of the denominator. So those are the two rules that we're going to look at today. In the chapter on exponents, I gave you a little table that has, a summary of all the perfect square numbers, or when you're raising a certain number to an exponent. So I have some of those here. So for the first numbers 1 through 13, the second column are, the numbers in the second column are the perfect squares. So for example, if you square 2, you get 4, 8 squared is 64, and so on. So it's similar to what we did before. I also have here the column for perfect cubes. So 1 cube is 1. Let's say 3 cubed means 3 times 3 times 3 is 27. 5 cubed is 5 times 5 times 5, which is 25. Now, this is a new addition to the table we're going to look at. This may be very helpful down the line, especially when we're solving by getting the square roots. When you don't have a calculator, so you can just refer back to this table if you need. Let's say square root of 5 is 2.2, square root of 8 is 2.8, and so on. If you don't have a calculator, by the way, you can use decimals.com, or you can also download some apps on your phone if you don't have a scientific calculator at home. Okay, so let's move on. How do we simplify square roots? Before we answer that, I'm going to copy this table on the new page we're going to look at. I'm going to make like a small version of it. There we go. So if you don't have a calculator ready for you to use, then we're just going to refer back to this one. Okay. So our first task is to learn how to simplify square roots. The first example is the square root of 108. If you enter that in your calculator right away, you will get somewhere around 10.4, rounded off to the nearest tenth. Okay, but at this point, that's not what we want. We want to simplify it by, still leaving it in radical form. Okay, so what are we going to do? Well, if you look at the column for squares here, okay, let's find a number that can divide 108. Okay, so, well, everything is divided by 1, so skip that. You can divide by 4, you can divide by 9, you can divide by 16, 25, and so on, right? Now, let's look at two possible ways. Suppose I use the 9 as a divisor. So if I factor 108 using 9, this will become 9 times 12, right? Then we can break down 12 further into 4 times 3. So that means square root of 108 is actually the same as the square root of 9 times 4 times 3. But according to the product of radicals rule, we can actually split that into square root of 9 times square root of 4 times square root of 3. So simplifying it further, the square root of 9, okay, this is a perfect square. The square root of 9 is 3, and then the square root of 4 is 2, but 3 is not a perfect square. See, it's not under the second column. So that means the 3 will stay inside the radical sign. And then we just have to simplify these together. So 3 times 2 is 6, and then just bring down radical 3. There you go. So that's the final answer that we want. So that means square root of 108 in simplest radical form, meaning not using decimals, is the same as 6 radical 3. Now, is there another way to do it? Well, let's try again. Let me erase this one and let's try solving the same problem using another set of factors. Okay, so let's try 108. I tried 9 earlier. Let me find another perfect square number. Well, 25 doesn't go into it. What about 36? Yes, it goes into 108. So 108 is 36 times 3, right? Okay, and we know that 36 is a perfect square number already. So if I break it down further into 9 times 4, then I'm still using the original method that we used. So let's stick with 36 times 3. So 108 will now be equal to square root of 36 times 3. And by the product of radical rules, or the multiplication of radicals, you can break it down into square root of 36 times square root of 3. That's a times, not a plus. There you go. Okay, so what is the square root of 36? We know it's a perfect square, and the square root of 36 is 6. So that means 6, this stays inside the radical sign, is 6 radical 3. So this is the same as the answer that we got previously. So what's the most convenient method to use? Like, what's the fastest way? Well, the fastest way is if you can find, if you can find the largest perfect square number, that is a factor of the given radical expression, then you can break it down into less number of factors. But, sometimes the obvious ones are easier to use, like the 4, not 4, but the 9 that we used earlier. So you'll know that you will arrive at the same answer. So no pressure. As long as you spot a perfect square that could go into a particular number, you can use that to break it down. Okay, let's do this example that has a variable. Well, we know that 9 is already a perfect square. So just leave it like that. Square root of 9, right? And then square root of x to the third power. Now let's focus on the x to the third power. Since we're trying to get the square root, we want to break down the exponents into multiples of 2, right? So this can be broken down into x squared and x. So that means you can break it down into the square root of 9, which has been there originally, and then square root of x squared times the square root of x. Okay, so if you get the final answer, the square root of 9 we know is 3. The square root of x squared, remember there is an invisible index here, right? And you can actually write this as x. The exponent is 2, and then the index is 2. So 2 divided by 2 is 1. So x to the first power. Or in other words, you can think of it as the square root of, x squared. The radical sign and the exponent cancel each other out. So that turns to just x. Okay. And then this one, square root of x, the exponent here is 1. Right? So if you divide that by the index here, which is 2, that's not going to be an exact answer. So that means it has to stay inside the radical sign. So the final answer for square root of 9x cubed is actually 3x square root of x. So that's the final answer that we're looking for. Alright, so those are examples on how to simplify square roots by using the product property. Okay, here's some more. Square root of 24. So we know that square root of 24 can be broken down into square root of 4 times square root of 6. Now what is the square root of 4? It's 2. Now 6 is not a perfect square, so it stays under the radical sign. So that's the final answer for the first one. Next. So 80 can be simplified into 16 times 5. Okay, 16 times 5. Or you can also go for, 4 times 20 and then break it down further. Okay, so we have negative 16, square root of 16 is 4, and then 5 stays inside the radical sign. So that's the final answer. So be careful when you have a negative sign. Next, 49. 49 is a perfect square, isn't it? 7 times 7 is 49, so we can isolate that. And remember what we did with the x cubed earlier? We separated even powers, so x squared and then x. So square root of 49 is 7, square root of x squared is x, and then the radical x stays inside. So that's 7x radical 7. Alright, so 75 is 25 times 3, right? Now n to the fifth power can be broken down into, so what's the highest even power? You can take out from n to the fifth power. It's going to be n to the fourth, right? And then you separate the remainder, n. So square root of 25 is 5. Okay, 3 is not a perfect square. Square root of n to the fourth. So remember the index is 2. So you go 4 divided by 2 is 2. So the square root of n to the fourth is n squared. And the radical n is not a perfect square either. So let's just do a little bit of regrouping. This will go side by side, 5n squared. Now since these two are not perfect squares, you can put them back together inside the radical sign. So the final answer is 5n squared times square root of 3n. So that's how we use the product rule for simplifying square roots.